Hello and welcome to Sustain, the podcast where we talk about sustaining open source for the long haul. Who are we? Where did we come from? Where are we going? What do I do with my code? Oh my God, oh my God, oh my God. What do I do with my code? Very excited to talk to our guest today. I'm the solo host in this podcast. It's Richard Littauer. Hello, everyone. I'm joined by Marianne Bellotti, calling from the Eastern Seaboard. Marianne, how are you doing today?
I'm doing great.
Great to have you on. And I'm also joined by Greg Wilson. Greg, how are you doing?
Doing all right. Greetings from Canada.
Greetings. So Marianne and Greg are on for a bit of a special episode. Marianne is an author who has been working for a long time in the open source sustainability, generally tech space as a whole. You might have heard of her book, Kill It With Fire, also hiring engineers. Kill It With Fire is basically, I got all this code. It's really bad. What do I do with it? What do I do with it? It sounds like a great book. I'm looking forward to reading it. I haven't read it yet, but that's super, super exciting. And she works at a nondescript day job. But basically, that's why she's here. And Greg co-founded the Carpentries, among other things. He currently works for Plotly up in Montreal. He's very proud of being Canadian, but also he should be proud of his long, distinguished career helping people do better open science and helping people share their code better and work and learn about code better. So that's a brief introduction to both of our guests. Now, as opposed to just a normal discursive topic about how did you get into coding by diving into dumpsters when you were 5, our goal today is to talk about a paper that Greg and I and 20 other people have written together, which I think we settled on the title, Quick Tips for Making Your Code Last Beyond Your Current Job. Initially, 10 simple rules for making your code last. This is a paper that's pretty much a direct result to the tumultuous times politically that we're living in, where there's many people who have had awesome opportunities and awesome jobs building things that are amazing. Things like NOAA or the CDC or the National Park Service, people who've been coding amazing things and suddenly having to find other jobs for very nondescript reasons. And what happens in that case to their code, right? Does it get lost? Research that's been published gets cited and is out there, but your code that you were sort of using to do stuff, infrastructure stuff, depends upon you a lot of the time. And so the paper is an answer to that. It's saying, if you know you're going to have to leave and you're going to have to leave quickly, here's what you can do to make your code last. Now, that's a lot of me talking. Greg, do you think that's a good summary of the paper? Do you think I could say something more?
I think it's a good summary, but I also think you're being a bit optimistic, which is unusual for you. The question I've had ever since we started work on this is whether code that is abandoned because somebody's funding was cut on short notice winds up in the dumpster any more or less often than other scientists' code. Because I've got to say, almost all of the researchers I've met in a 40-odd year career write code for themselves. Maybe one or two other people copy it onto their hard drive and forget where it came from. And that's the end of the story. That's the norm in science. So what we're seeing now is possibly business as usual, just happening really fast and in the spotlight. And I don't want to be a depressing person, but 2 or 3 years from now, some grad student in software engineering is going to publish the study that says, you know what? It was what was going to happen anyway, given the way most researchers manage their code. It just happened all at once and we noticed.
Well, that's too depressing for me to comment on. Marianne, you got any thoughts?
I don't interact much with the academic community and the research community, to be honest. I would like to interact with them more. But the thing that I have noticed when I read different papers and interact with that community is very often they don't actually put their code in a place that is publicly accessible for people to look at. And I've talked to a couple of my friends that are in this space, and the consensus sort of seems to be that they do not escape the imposter syndrome that us in the professional software side live with every day. That there's this constant fear of, if I put my code up, someone will find a problem in it and that'll invalidate like everything. So I'm just going to keep it in my space and not on GitHub. But I have read great papers where I thought, this is amazing. I really want to like play around with this code, maybe add to it. And then I can't find it anywhere. So I do agree that I think the general trend in these fields is to lose a lot of work that's been done and to not have it survive at all, largely because of that desire not to expose possibly your own vulnerabilities and shortcomings as a software person.
If I could jump in and contradict what I said just a minute ago.
Yes, excellent.
So one of my previous employers was doing machine learning for drug discovery. A lot of people there who have backgrounds in biology and are self-taught programmers who've become data analysts. Every one of them, with the blessing of the company, had a GitHub repo called your user ID-sandbox. And it would be full of Jupyter notebooks or our markdown files, each of which was one analysis they'd done, one experiment they'd run, one result they were expected to get.
Wow.
Nobody else could navigate these repositories because it's your personal record. If you've been at the company 5 years, there are, in one case, literally thousands of Jupyter notebooks in this repo, and you're the only one who understands how they're organized. And the software engineer in me kind of throws up in my mouth a little bit at this. But it was the right workflow for them because they're not building a product that they're expecting to run over and over again just on different data. Every single one of those notebooks is qualitatively different because they're doing research and they're trying to answer different questions. And one of the things I've realized since I started the Carpentries, whatever it is now, almost 30 years ago, is that a lot of the mindset that we have as software developers is inappropriate for people who are doing research. One of the other examples of this is it doesn't make sense to write unit tests for a data analysis pipeline of the kind that Marianne and I would write for something that's going to be a product that goes into production. Because if I knew what the right answer was, I would have published the result and I'd move on to the next problem. How do I write the unit test when I don't know what the answer is, or when it is specific to this one particular data set and I need to know one thing about it before we go on? We're not in production. I think a lot of scientists are constantly in a prototyping world. And the challenge then, of course, is that somebody looks at their prototypes and says, oh, goody, let's put this in production. And 20 years later, Marianne is writing a book about it.
I want to step back a bit. So we've talked a bit about research, and researchers have their own problems, and grad students have their own problems. Lord help me, I know, I am one. But what's interesting about this paper is it wasn't just focused on researchers. It's focused on career civil servants who have to leave their job really quickly. And it's also, after discussions with other authors, focused on anyone who wants to move on to another job. If you're going to move on to another job, your code should be in a place where other people can pick it up if they need to, or where you can pick it up if you need to at the next job. Wouldn't that be great? And you wouldn't have to just put everything aside and recreate all your tools again. It's kind of a best engineering practice to talk about what you're doing to yourself in the future using documentation and to write code that's really clear. Now, no, we can't always do that. And yes, sometimes we are performing one-off 200-line shell scripts and then they're gone forever, and that's fine. But in an ideal world, everything can be repeated and everything can be used later, and there's no wasted effort and no wasted space. Now, this is not that world, and it will never be that world. But the idea is kind of, let's talk about how do you get there. So I think now that we've set the scene a bit, it might be fun to actually just go through the paper because there's multiple section headings, and each section heading has a number and has a particular theme. Again, this started as 10 simple rules for making your code last. So with that, Greg coming from the research side, Marianne coming from the industry side, having seen where all the bodies are buried, we have this step one here, which is if you're going to leave your job for any reason, consider your threat model first. Now, Greg, you wanted to write this one. What does this mean?
Anybody who's doing disaster planning has to think about what disasters are we planning for. I grew up on Vancouver Island off the west coast of British Columbia. We don't get tornadoes. We get forest fires. It's a different problem. So you make different kinds of plans for that. So if you're thinking about the threats, is this an individual threat like Marianne might move on from this job and she's the only one who understands the database driver? That's very different from, is our entire department's funding going to be axed and all of us are going to be scattering at the same time? And that's a different threat again from the sort of extinction level event we're getting right now, which is all of the departments are getting axed. So there's nowhere for us to go to. So this entire community becomes a diaspora that loses touch with each other. I think we need different responses to each of those. And it's not just a case of how severe is it, it's also what's the time scale. If Marianne leaves her job, 3 months, 6 months down the road, somebody else will have been hired in and will have taken that over and will be climbing the mountain that is that code base, hopefully with oxygen and pitons. If we have some sort of extinction level event, it could be years before we're even in a position to think about doing any sort of refactoring or overhaul on this code. And I think some of the work that Marianne has done with government agencies, where you see, because of changes in administrations, you'll see enormous layoffs, nothing happens for years, and then the department gets revived, and now there's a chance for fresh growth. That's not really something that science has had to deal with in my lifetime. And that's one of the reasons why I was so fascinated by her book. What do you do if the entire generation that built this is gone, and now it's your problem?
Yeah, I would add to that. I think it's really useful to think as broadly as possible about impacts and threats. One of the favorite pieces of advice that I got in my journey as a software engineer was weapons begin as toys, right? This idea that the things that really become very powerful, no one ever starts from the perspective of I'm going to build an innovative new weapon. They generally start experimenting with different types of technology and different ways of applying them in an environment where it feels very low stakes, where it feels like there are no, like, this is just a nothing thing, right? And so if you want a modern day example of this, you can look at the social media. There were years and years and years and years of engineers in those companies that just thought, nah, this is just for people wasting time on the internet. This is just a toy. There's no real meaning in it. There's no real impact in it. They got caught by surprise quite dramatically, the type of problems that they were opening up in their design decisions. So I like to hold that idea philosophically in my mind whenever I'm approaching any kind of software project, that if I find myself thinking, this is just a toy, or this isn't important, or this is just a tool for people to waste time or what have you, to try to think critically about that assertion, because everything that's been truly dangerous in the world often starts as a toy on some level. But I would add to that, the other thing that you should think about when you're thinking about threats and risks and impacts is, what is the actual cost of this thing that you're building actually not existing? Because I think we tend to want to flatter ourselves and think, well, this would be awful because would have a less efficient way of doing a thing. But the less efficient way of doing a thing is not no way of doing a thing. And I think that should shape how you approach what you're building and why you're building it. And I have a friend of mine who loves to say, I don't want throwaway code. And I usually respond to this as, all code is throwaway code, because it exists in a particular moment, in a particular context, and it serves a particular cultural purpose. All of those things tend to shift over time. So there will be a time when none of those things are relevant. So all code at some point, I think, reaches its natural life cycle and needs to be either rethought, re-architected, or just deleted altogether. So understanding where what you're building is in that life cycle. Is it the life cycle of a tortoise, or is it a life cycle of a fruit fly? And there's no value judgment in either one. The fruit fly code is still really, really powerful and really useful in its prime. So I think being really clear about that is really important as well.
I think I would add that When you think about a threat model, it's often talking about other actors. But another way of reframing it is, will this be useful for me in the future? And how will it be useful for me? And if it's lost, how will that be hard for me? Just focusing on that simple question can help clarify a bit more. What should I do with the code that I have? It's not a perfect question. It's just another reframe of what threat modeling can mean.
Yeah, absolutely. You can't anticipate everything, right? So you cannot anticipate completely paradigm shifting changes in technology. And the best example of that is the conversation about quantum computing and encryption. There is no time machine we could get in and go back and say, like, by the way, you should think about quantum computing and then like roll out an encryption algorithm that's going to resist that. There was no way of foreseeing it. There was no way of thinking that far ahead. And that's true for all technology. Okay, I'm going to take the second one. The second simple rule is get sign off on releasing it publicly.
I think that's much easier these days in an academic environment than it is, for example, in the civil service or in a government research lab or in a company. So this is one where I think Marianne probably has more experience of the challenges of getting somebody to say it's okay, even if they don't think there's any reason not to. They just don't think they have the right to say yes.
It is a very challenging one if you're in the private sector, depending on what type of company you're at. There are lots of companies these days that will call themselves technical companies that do not have the culture of other companies that are more ingrained with the community, right? So there are technical companies where they understand the value of open sourcing things and how that builds a brand among potential hires, how that creates thought leadership and all of that. And then there are lots of companies that look at it as like, this is our IP. What do you mean release it publicly? That's not a thing we do, right? And so knowing the culture of the organization that you're in is really important. Figuring out if there are any existing advocates for open source is really useful. If there are, talking to them about their experience and seeing if this is a thing where you can sort of hook it to their integrity and social capital in the organization, or if it's a thing that hasn't gained momentum yet. And then another thing to think about is where something starts on this point is more important than where it ends up. And by that, I mean, there are a lot of companies that are 100% okay with using open source code, but they don't want to open source their own code. So if you have an idea for building something that you would think is useful to your company, you want it to be open source, you feel like they wouldn't really be into open sourcing it, then you should start it as a personal project, open sourced with an appropriate license, and then bring it back and say, hey, I think this could help us on project XYZ. Let's take it through the security process. Let's take it through whatever the evaluation process is, because then it's already open source. And so you're not going to get pushback about continuing to contribute to something that's already open source.
I like that. It's difficult if you're leaving your job to have the time to think ahead, to think about how things are going to work. And so in an ideal world, you've already figured out beforehand your contracts, and somehow all the work you're doing is going to be open source and free, and you're going to get paid for it at the same time. It can happen. It's not impossible, but it's rare. If you're in a situation where you know you're going to leave, getting sign off is really important. It is possible sometimes. I really like find the open source advocate. They're the people who are going to be able to help you out. When I wrote this, I was also thinking particularly about some friends of mine who work for, say, Fish and Wildlife, where they do have to jump through a process, even though it's public money for public code. They do have to get some sort of sign off or technical oversight before they can just put it out there. And so just go through that process quickly. Try to get that done first, because it'll make everything easier, and you don't want to do a lot of work and then find out no one can see it anyway.
Yeah, the equivalent to find the open source advocate in government is also find the lawyer, because there are a lot of people who will tell you you can't do that. That is illegal. That all they're trying to do is shut down the conversation. Like, it's not actually illegal. It's just a very quick way of eliminating the conversation. And like, the government cannot own IP. So the idea of you can't open source this code because they can't own IP. So usually that's kind of the vehicle to getting things out into the public that maybe didn't start there. But yeah, like finding the best thing that we did when I was in government is we found a bunch of lawyers that were friendly to our cause and started coordinating with them. And then our lawyers like argued with their lawyers and like they had a big lawyer fight and we figured out a path forward through that.
On that note, something that I've stumbled over in my career, depending on what institution you're in and the time of the day and which direction winds are blowing across the glaciers in Finland, your institution might actually have a legal mandate to realize the commercial value of the research it's doing. There's a push to do tech transfer, and I support that. But what that means is that even if everybody involved believes that this should be open sourced or should be open access, they can't legally do it until they prove it has no value, which is in practice impossible to prove. And this brings us back to the problem I see where nobody is saying no, but nobody feels that they have the authority to say yes. And it's not just CYA, it's not just they're afraid it might stick to them. Many organizations don't have a person who is allowed to say, yes, this can go out. And that's often the biggest bureaucratic hurdle is, I don't know, it's not in my job description. In fact, it's not in anybody's job description. So we'll get back to you. How is never?
So finding that advocate, finding your allies in your organization or people who work in similar organizations can really help with identifying how do you get over that hurdle. So that's the first step. Don't just release stuff without getting sign off. If you need sign off, if you don't know, find out. And then you can move on to the next one, which I think, Greg, it's your turn.
Sure. Choose an open license. I hope that at this point, this is a no-brainer for everybody doing research. Just put it out there under an open license. A lot of my stories aren't true, but this is a true story. When I was faculty in computer science at the University of Toronto, I spent 18 months trying to get approval from the university to release a small project that one of the undergraduate students had done as open source. And as I said a few minutes ago, nobody was going to say no, but nobody felt they had the authority to say yes until, in frustration, we changed from the BSD license to the MIT license. Now, two people on this podcast are looking puzzled because those are legally equivalent. The difference was nobody at the University of Toronto knew what BSD stood for, but they had all heard of MIT. And if it's good enough for MIT, it's good enough for us.
Oh, that's amazing.
Which sounds ridiculous, but it was the cover that they needed bureaucratically.
What does the B stand for in BSD again?
Berkeley, sure. But, MIT, yes, you're laughing, but I completely understand how that machine works and how it leads us to that place. And I don't think that as programmers, we get to point the finger at anybody else's weird rules having weird interactions. This is our bread and butter.
Yeah.
Okay? These days, for my personal projects, I'm using ethical licenses like the Hippocratic license because I enjoy watching people squirm. If you read the text of the Hippocratic license, it says you're not allowed to use this software for anything that violates the UN Convention on Human Rights. All of our countries are signatories to that. I'm not actually imposing any legal restriction that isn't already there, but boy, howdy, is it fun watching people dance around that one. I wouldn't do that if I was trying to get this software out of a university or out of a government lab. Why poke the bear? I'm deliberately making my life difficult. Pick one of the 3 or 4 well-known licenses. Stick with it. There are other battles you need to fight. Please, for the love of all you hold holy, don't try to write your own license.
Please don't write your own license, people. Please don't do that. If you really want to do that, check out Blue Oak. Blue Oak has some awesome license templates that are really, really cool. And Kyle Mitchell and the other people there are amazing. So there are opportunities if you want to write your own, but don't. Just don't. Please don't. Marianne, any other thoughts?
Nothing you said, Greg, was a surprise. Like literally, I could 100% believe that the MIT brand name made all the difference, right? A lot of times, comfort and security and the feeling of emotional well-being is the root cause of a lot of technical decisions, particularly in large organizations that are not technical organizations, like government organizations. But another thing I tell people all the time is that there are scenarios when you're dealing with large, complicated, failing systems where failure is preferable to success. Because if you fail exactly the same way everybody before you has failed, you cannot be singled out and criticized for that failure. It was literally the same way everyone else failed. There's nothing unique about it. But if you do something different than what everyone else has done, than what everybody in the government has done before, and it succeeds, people will still look at it as, well, yeah, but 5 years from now, 10 years from now, like, it's successful now, but will it ultimately be successful? And so you'll watch people make these kind of decisions. So like 100% can believe that like MIT was the tipping point on getting buy-in from that.
The next step is put your code somewhere safe. At the top of this, we have I mentioned the phrase locks, lots of copies, keep stuff safe. This is pretty self-explanatory. If you're going to take code and put it somewhere after you've gotten sign off, after you've licensed it, make sure it's like somewhere, right? Don't leave it on your hard drive. Don't leave it in your Gmail archive. Throw it onto Codeberg or GitHub. Put it on an institutional repository that you have somewhere with your institution. If there's a national archive where you can store it there, if there's an international one, even better. There's places like Open Science Foundation and Zenodo and Figshare and Software Heritage where you can put assets related to your code or sometimes just the code itself. Zenodo has a link with GitHub where you can add a DOI to it so it's easily referable and citable later, which is really exciting. And you can cite different versions with different DOIs. So this is just plain and simple. Another place you can put your code, if it's packages, is on package managers, NPM, PyPy, CRAN, CCAN. There's places where you can put stuff. So put stuff places. That's the core here.
One of the failed experiments that I really wish had succeeded was a project called BioTorrents. And the idea was you create torrent files. Here's my data set. And over the last 60 days, we've seen a whole bunch of torrents pop up of US government data sets because, quite rightly, people are afraid this is going to disappear. I've spoken to Richard about the nightmare scenario, which is some judge discovers that there is something they don't like on GitHub, and GitHub gets shut down on short notice. There's no legal or technical obstacle to this happening. And yes, we all have copies of our repos, but I don't have a copy of all of my code issues. I need to clarify that. Right? So the idea that any one of these repositories on its own is like saying, yes, we put a copy in the Library of Alexandria. Sooner or later, every library burns, right? And we invented something that was peer-to-peer distributed, incredibly robust, but because it was associated with software piracy, most institutions have firewall rules or some sort of protocol in place to stop that from being useful. And we're at the point now where we should revisit that because torrent files are an incredibly robust mechanism for sharing data and code. It's looking more and more attractive. So if anybody out there is looking for a startup idea / humanitarian project / whatever, I think this one is actually worth investigating now.
Yeah, I would add to that, if anyone's looking into startup ideas and likes that one, please also think about identity verification on top of it, right? Because I love the idea of using torrent to like redistribute code as a failsafe, but like, man, I would not download a software package that I got from just a network somewhere out there, right? So sign your commits. It's all good. Sign your commits.
Another way you can share code, I think people don't often realize, is that if you have a colleague who knows about your code, just ask them to clone it on their computer. We often talk about bus factor or replacement factor. You know, what happens if you have to go away real quick? Just having a group of peers and saying, hey, can we all just share each other's code is actually a good enough step a lot of the time. And it's something you can do. So just think about alternative ways besides torrenting or uploading to various websites. Just share your code where you're going to share it.
All right, number 5, document your code. This one is actually close to my heart. It's like aspirational. Almost nobody does it for real, but everybody agrees it's the right thing to do, right?
I came to the conclusion a while ago that the reason most people don't document their code is that they don't know which bits of documentation are actually going to be useful. Most documentation is never read by anybody because it's not answering the questions that you actually have. And I could ask Marianne this, the legacy systems that you've worked with over the years, how often do you think the original author 20 years ago could have anticipated the question that you're going to have? The thing you're trying to integrate it with didn't exist when they were building that software in the first place. I don't want to drag us down a rabbit hole, but this for me is the single most compelling case for the use of LLMs in software. Because I can ask the software questions. I can ask the Slack archive plus the issue archive plus the code questions and get better answers than I will get from people who are up against a deadline, who are trying to anticipate what somebody might need 5 years from now. And that's not just a supposition. I'm finding that right now over and over again. Provided that we've archived the human conversation around the code, the email, the Slack, the issues, the Google Docs, the Confluence pages, whatever else, as long as that's there with the code. There's a startup in Vancouver called Observable that are building tools to do this. There's several companies building tools to do this. Theirs is the one I've tried out. And their goal is to be as good as the programmer who wrote this a couple of years ago but hasn't touched it since. On the one hand, she's likely to get a couple of the details wrong. On the other hand, you have been in times and places where you would absolutely have paid for the plane ticket to bring her on site for a 30-minute conversation to just say, what the hell? Why is Belgium a special case? Sorry, that's past trauma intruding into present day life, but you're staring at the code base and it's like, if you're in the EU but not Belgium, here's the if statement. Otherwise, if you're in Belgium, do it this other way. And
why do we have all of these people who are over 100 years old in Social Security, right? Like, tell me. So I've not had great results with using LMs in that fashion. I agree that from a theoretical perspective, I think it's there, right? I think it's possible. I've not had great results with LMs in that way, largely because, first of all, when you said the Slack history, I was like, ha 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 ha, right? We're talking about real old systems. We're talking about maybe there was an email thread 20 years ago, maybe, but probably not. So we often don't have that context. We just have the code. And then the other thing that I would say is that I think a lot of people don't actually know what the really critical pieces of documentation are. So number one on my list is, how do I run this damn thing? Like, how do I build it? I can't tell you how many times I've opened up a quick start file and there's a bunch of narrative about the origin of the project, but not actual instructions about how I'm supposed to run it and what sort of dependencies I'm supposed to install before I run it. That for me is vital. And I have yet to see an LM be able to reason through like a list of dependencies and look at the code and go, oh, you need to be running these commands and have these things installed beforehand. That would be great when we get there. And I'm optimistic that we might get there one day, but we're not there today as far as I've seen. When I have a new piece of code that I'm going through, I don't go to the docs first. I go to the tests first. If there are tests, wherever they are, if they're unit tests, great, excellent. I open up the test folder. If they're like end-to-end tests that exist in some weird place, I go there. If they're manual QA style tests, that's where I go. Because that is essentially the beginner's version of a specification. It's this thing gets this input and outputs this as a result, right? And you learn so much about how the programmer thought about what they were building and intended it to be used just by what they're testing for and what they expect to get out of those tests, right? So I tell people, do not think of documentation as just a README file in your repo. Your tests are also part of your documentation.
I've never heard that before. I really like that. For me, when I think about documentation and the things people forget, it's the stuff that you say to your friend when they ask you to describe it in 5 minutes. Oh, yeah, no, this is actually run by two of us, and we both get sign off from each other first, but also we only really push on Thursdays or something. Like the stuff that's really useful to know, it's never written down. Governance. Governance should be in the repo. Explain what the project's for, why it started, and why, you're never going to touch it again. Those are things that should all be documented. I know we think about documentation as being how to run it, how to contribute, how to write tests. But a lot of it's also, hey, this was funded, now it's no longer funded. That's really useful for people sometimes, for people who are coming to a new project. And there's no reason that can't be written down. If you can say it verbally, you can probably write it. It's kind of another way of looking at documentation. So I'm looking at the rest, and I'm looking at how far we've gotten, and we really only have around 10 minutes left. So I think we're going to limit our conversation quickly just so we can get through the next points. So 30 seconds or less. Make your code reproducible. That can be covered in 30 seconds, right, Greg?
As Marianne just said, can somebody else build it, given what's actually there with the code? We've made tremendous strides on this. Tools like UV for Python, block files, things that give us exact version specifications, Docker environments, stuff like that. The world's a lot better than it was 10 years ago on this front.
Yeah, agreed. I would add to that we often talk about the building of software as if it is a solitary endeavor, but most software is built by teams. So actually leveraging that fact to your advantage and figuring out the roles of each person's building this software and how to get it to enhance your documentation, enhance the reproducibility of your code. Like, remember, you're not writing this code alone. And if you are, it may not actually be useful enough to share with other people and like extend its life past your employment in a given situation. So just think about who the team is.
I think that rolls right into our next ones, which I'm just going to say together, which is make your code citable and encourage community adoption. Your code needs to be able to be used by other people. Make it citable by add a citation file, citation.cff file, saying, hey, here's how you use it. But talk about it with other people and try to encourage other people to come on board with you. And this is actually relatively easy to do at the end of a project too. You don't need to do it at the beginning of a project. You just say, hey, this is a cool thing and here you can help out. And here's how you can use it later and here's how you can cite me for it.
One book that really changed how I view all of this is by Mark Kushner, and it's called Marketing for Scientists. He's a NASA mission scientist, but he also writes and sells country and Western songs in Nashville. And this book is everything he learned about marketing from Nashville that scientists ought to know. And one of the points he makes early on is that most scientists think that their papers are their product, and they're wrong. Their product is their grant proposals. That's what brings in the money. The paper is the advertising. And most scientists, most researchers, not just in academia, but elsewhere, do an absolutely crappy job of telling people, why should you care? Why should you be interested in this? So if I could change one thing, it wouldn't be write more documentation about the code. It would be give me 3 paragraphs that makes me care enough to read the documentation or try out the code.
It had never occurred to me before I read this that my code might be citable. And now I have like a great list of references on how to do that and think about that. And I'm really excited about that. So I, for one, have learned something already from this podcast.
We have a few quick tips hidden in among the quick tips that are really fun. One of them, a citation.cff file, is amazing. Another really interesting thing in this section of community adoption is if you get one person from one other institution to commit to your repo, to add a commit, suddenly you have shared IP, and it's a lot more difficult for anyone to remove it. And it's a really neat trick discovered by a single scientist. Just get someone else to work with your code with you, and then all of a sudden it's like, oh, well, we can't take that down because it's shared with this other organization. Super, super fun way of just hacking the legal system. Make it a community effort. The next point was kind of 2 points brought together. It's write a succession plan or write a sunsetting plan. Be really intentional about your code. Recognize that you're not going to be able to keep it going forever because you also have a finite time span in this world. And so figure out what's going to happen to the code. Either figure out how you can give it to someone else or figure out how you can mothball it and just say, this was a beautiful time in my life. And now I will look back in fondness on it as I do other things.
Something that I do because I mostly work professionally on the management layer. I'm concerned about how engineering orgs are running and growing as well as what the technology looks like. When we're talking about laying out a policy, I'll insist upon 2 things: success criteria, but then failure criteria. Why are we doing this thing? What are we hoping the tangible results from doing it are? But then also, if we were to get in a time machine and go 10 years in the future and someone had completely perverted this policy and used it to do the absolute worst thing we could ever imagine, what would those things be? Because I think people tend to need feedback. Like sunsetting is a really hard thing for people to do. It takes a lot of socialization and coordination to sunset something. So to be able to explicitly say, if you are seeing these things, it is time for this piece of code, product, whatever it is to go, helps people a lot. It helps drive the momentum. It helps encourage the organization to do the right thing. So I do think like thinking about it really explicitly, what is the anti-pattern? What is the negative result that you can foresee that might mean it's time for this thing to be sunsetted is incredibly valuable to whoever is taking it over in the future.
Our final point is talk about what you're doing. Greg, why is this important?
We talked a little bit earlier about the marketing, about let people know both what this project was and that it's reached end of life. It's really uncomfortable and I think unfair for people to be relying on something that's no longer maintained, for them to be mailing an address that's no longer being looked at. But the flip side of this, and the one that isn't yet in the paper but will be by the time it's published, is that you need to take some time to celebrate and to grieve. We tend not to do either as often as we should. When I left software carpentry in 2017, one of the things I did at a friend's recommendation was go and see a movie called The Last Waltz. And I don't know if either of you have seen it, but the band had played together for years and years, but they were fighting, they were bickering, they were headed in different directions. And rather than just have the whole thing grind to a halt, they said, we're going to get all of our friends together, which at the time was pretty much everybody in American rock music, and we're going to do one last blowout show. I think it is worth doing that more often than we do. I think it is worth having one last dinner, one last t-shirt, one last set of laptop stickers. I'm not going to try to show it. It's on my other laptop, but I actually have a sticker, which is a project name, and underneath it, it's 5.6, the final release.
Yeah, more of that. More celebration, more grieving, more being human with our code. Part of the section talk about it is also telling people to talk about this whole process. Talk about this process of going through stuff because we think it's useful and we think it's cool. And we also want to hear from you. This paper is meant to be a living document. So we're setting up a task force with RISA, the Research Software Alliance, and with Curious and with Sustain, probably all three of us together, to basically have a year or so run line to build a Jupyter Notebook type document where other people can contribute other tips that they think weren't included in the 10 that we just listed. And so do read the paper. When this podcast is out and you are listening, you will be able to read a preprint. So please go check it out, read it. And if you see that we're missing something, you can contribute back. And that would just be super, super awesome. I don't have time today to do all the spiel about Sustain and how it's awesome and how you can donate or go to podcast@zenodo.com. But I will say, talk about the podcast, talk about the paper, share it with your friends, share it with your colleagues, share it with people you know who are having to leave their jobs. Our entire point in writing this is to make it spread so that people know how to say goodbye to their code.
Could I add one last note before Marianne says goodbye? There's a step that isn't in the paper, and that is, once you're done all of this, please get out and organize. What American science is going through right now is a catastrophe, and the only way we can stop it getting worse is by working together. And I realize that that feels really awkward to a lot of people. The habit of collective action, even the word union, has become socially uncomfortable for a lot of people. But we organize or we lose.
Yeah, find your team. You are never working alone on anything, even if it's just the people who consume your work or the people that contribute to your work in a non-code based way. Find your team. That is the easiest way to get things forward and to ensure their survival.
Thanks, team, for talking with me today. It was good to meet you both. It was good to talk to you both.
Yeah.
Thank you, listeners.